So this is part 2 on normal distributions, and here is an example. So the age when students graduate from college with an undergraduate degree is normally distributed with mean 24.5 years, has a standard deviation of 1.5 years. So what we know is that the mean is 24.5 and standard deviation is 1.5. With that information, we want to find the probability that the age when students graduate from college with an undergraduate degree is between 22 and 25. So we can call X to be the age when students from college with an undergraduate degree. So we know that the mean is 24.5 and the standard deviation is 1.5. So 22 is probably somewhere over here. You don't have to be exact, we're just looking for approximate locations, and 25.5 is perhaps over there. And what we are trying to find is the area between those 2 points. So how do we find the area? We make use of the calculator. So 22 is over here, 25.5 is over there. So press second vars and go to normal CDF, which is option number 2, and you enter the lower endpoint. The lower here is 22. The upper is 25.5. So 22, comma, 25.5, comma, the mean, which is 24.5, and the standard deviation is 1.5. If you have a newer version of the calculator, the lower, the upper, the mean, and the standard deviation would be listed in rows. All you have to do is enter the appropriate numbers in each row and hit enter. So when I press enter, we get an answer of 0.6997. How would we interpret this probability? We can interpret this probability that the probability that the age of a randomly selected student to graduate from college with an undergraduate degree is between 22 and 25.5 is 0.6997 or 69.97%. There are multiple ways to interpret this probability. This is one way of wording it. Of course, there are other ways, and I'll try to go over all possibilities. So it is the same problem that we are continuing, but only this time we are trying to find the probability that x is less than 20.5, and our task here is to find it with and without a z-score. So first let us find the z-score. The z-score is simply the observation minus the mean, mu, divided by the standard deviation, sigma. So we have 20.5 minus 24.5 divided by sigma, and the value of sigma is 1.5. So we could find that value, 20.5 minus 24.5 divided by 1.5, we get negative 2.67. So we will just leave that for now. We'll leave that be and go here and mark down the mean. And let's look at the probability that x would be less than 20.5. 20.5 is perhaps over there. And we want to find that area. And observe that that area is quite small, which would simply mean that the probability answer that we are going to find will also be small. So the probability that x is less than 25, we can find it using the calculator. Press second vars. Number 2, the lower endpoint here is negative infinity. So in the calculator, it is negative E99. So press second comma to get E, and 99, that is our lower endpoint. The upper endpoint, this is lower, that's upper, and the upper would be 20.5, follow it by the mean, which is 24.5, standard deviation is 1.5. The answer is 0.0038, as we noted that even before starting the problem, that the probability answer is going to be very small because the area is quite small, right over here. So naturally, the answer ended up being small. If we use the z-score, we know that the z-score corresponding to 20.5 is negative 2.67. The only thing that will change when we convert an observation to a z-score is that that would get converted to the probability z is less than negative 2.67. Negative 2.67 is the z-score corresponding to 20.5. So here we will still use normal CDF, but the lower endpoint and the upper endpoint would remain the same, and the mean and the standard deviation would become 0 and 1. So we could enter negative 2.67, 0 and 1. So let's go back to the second bars. Number 2, negative second comma to get E, 99. Negative 2.67, which is the z-score corresponding to 20.5, followed by the mean and the standard deviation. Press enter. The answer is 0.00379, which is the same as 0.0038. It doesn't matter whether we use the z-score or not, in the sense we do it directly like we did here, the answer has to be the same. Now, we want to find the probability that x is greater than 20.5. So 20.5 is somewhere over here. And we want to find that area. And there are a couple of ways to do this. So we already know the z-score is negative 2.67. But before we even use normal CDF, we have to understand that probability of x greater than 20.5 is the complement of probability x less than or equal to 20.5. But when it comes to normal distribution, probability of x less than or equal to 20.5 is the same as probability x less than 20.5, because an exact probability is typically 0 with a normal distribution. That said, we can use complementary rule and recognize that the probability x is greater than 20.5 is equal to 1 minus the probability x is less than 20.5, for which we already have the answer as 0.0038. So 1 minus 0.0038 would give us 0.9962. Let's see if we get the same answer using the other approaches. So without z-score, the probability of x greater than 20.5 would be normal CDF. The lower, in this case, the lower is, or lower endpoint is 20.5. The upper endpoint is positive infinity, which in the calculator is simply E99. So we start at 20.5. We end at E99, second comma 99. The mean is 24.5 and the standard deviation is 1.5. And enter, we get 0.99616. Which is approximately 0.9962. If we do this with z-score, we know that probability x greater than 20.5 will get converted to z greater than negative 2.67, because negative 2.67 is the z-score corresponding to 20.5. So we do the same process, the mean would become 0 and the standard deviation would become 1. So if we plug that in the calculator, second comma, 0 and 1, enter, we get 0.9962, which is the same answer that we got in the last two approaches. So it doesn't matter which approach you use, we'd end up getting the same answer. So here we have a case where we want to find the probability with and without a Z-score at the age of a randomly selected graduate student to graduate would be at most 24. So 24 is somewhere right over here. And we are trying to find that area and even before you start the problem, if we think about this, we know that the area below the median, which is 24.5, which is also the mean and the mode for a normal distribution, is 50%. So 24 is very close to 24.5. So one can reasonably assume that the answer is going to be close to 50%. Let's see if we get that. So without Z-score, at most would mean less than or equal to. But for a normal distribution, less than or equal to and less than are one and the same. So that would equal to the probability x is less than 24. So we go back here to the calculator, second vars, and recognize that 24 in this problem is the upper endpoint. The lower is at negative infinity, which is negative E99 in the calculator. So we have normal CDF, lower endpoint, upper endpoint, mean, and standard deviation. So number 2, negative E99, 24, 24.5, and 1.5. Enter, we get 0.3694. So our initial guess that the answer is going to be somewhere close to 0.5 seems to be right, but we've got to be careful because the guess that we make is always tied to the standard deviation. So if you want to be as accurate as possible, just keep in mind of the empirical rule of standard normal distributions. I believe it was discussed in the previous video. So the answer here is 0.3694. Now we can do this with the Z-score. So probability x z would be less than or equal to the Z-score corresponding to 24. So let's find that. So here, x minus mu over sigma. X is 24, mu is 24.5, and sigma is 1.5. So 24 minus 24.5 divided by 1.5, and that gives us negative 0.3333. So what we're trying to find is z less than negative 0.3333. So nothing changes except for the mean and standard deviation when we use normal CDF. So number 2, the lower endpoint is still negative E99, The upper endpoint is negative 0.3333. The mean is 0. The standard deviation is 1. And enter, we end up getting the same answer, 0.3694. Just keep in mind that the z-score corresponding to 24 is negative 0.3333, and we obtain that using that formula right there. So it is the same problem, and this time we're going to try it with and without the z-score to find the probability that the age of a randomly selected student to graduate would be at least 22 years. So it's 24.5, the mean is right over there, and 22 perhaps is right here. It's just a guess. And we want to find that area. It is always good practice to draw this graph and shade it so that we don't make any mistakes. Even before we start the problem, we have to realize that the area above the median is 50%. In other words, the probability is 0.5. And we are adding a bit of area to what we already have. So whatever answer that we're looking for has to be bigger than 0.5. And here the area starts at 22, so that would be our lower endpoint. It ends at infinity, or E99, that would be the upper endpoint. So without z-score, at least 22 would mean x is greater than or equal to 22, but keep in mind with normal distributions, probability x greater than 22 is the same as probability x greater than or equal to 22. So we can use the calculator, second bars, number 2, we start at 22, we end at E99. The mean is 24.5 and the standard deviation is 1.5. And enter, we get 0.9522. So you look at that graph, it doesn't seem like 0.9522 area. It seems quite less than 0.9522, but that's okay because we just made a guess when we started the problem, but all we have to recognize from the graph is that the area or the probability answer that we're about to find is bigger than 50%. With the z-score, we first have to convert the observation to a z-score, and we can do that using this formula, x minus mu over sigma, which would be 22 minus 24.5 divided by 1.5. And that would give us negative 1.67. So probability of x greater than 22 is the same as probability z greater than its corresponding z-score of negative 1.67. So normal CDF, the lower endpoint is negative 1.67, the upper is E99. Keep in mind, when we convert it to a z-score, the mean becomes 0, standard deviation becomes 1. Second, vars, number 2, we start at negative 1.67, end at E99, the mean is 0, standard deviation is 1, and the answer is 0.9525. Slightly off compared to the previous one, so let's go back and check. Now this happens because of rounding and such, so this answer here is correct, and that is close. But we are getting a slightly different answer because we rounded that z-score to 2 decimal places. If you recall, the answer was negative 1.66666667. So it is always best to use the direct approach, in the sense without using the z-score and simply using normal CDF with the actual mean and the standard deviation to avoid discrepancies due to rounding. So here is another example where we want to find the probability that the age of a randomly selected student to graduate would be between 22 and 26.5 years. 24.5 is right in the middle, and 22 is perhaps somewhere here, and 26.5 is perhaps somewhere there. Mind you that this graph doesn't have to be accurate. It just gives an idea on where to start, where to end, and how much of a probability can we expect. So the starting point for the area is 22. The ending point is 26.5. And let's find it without the z-score. So what we're looking for is the probability that age x is between 22 and 26.5. So we could use second verse, number 2. We start at 22, we end at 26.5, the mean is 24.5, and the standard deviation is 1.5. And we get an answer of 0.8609. Now, with the z-score, this is going to be extra work because we want to convert the z-score of 22, we want to find the z-score for 22, and we want to find the z-score for 26.5. So the z-score of 22 can be found using that formula x minus mu over sigma, which is 22 minus 24.5 over 1.5. We get negative 1.67, and the z-score corresponding to 26.5 is x minus mu over sigma, where x is 26.5 minus 24.5 over 1.5. And we get 1.33. So the probability that the age is between 22 and 26.5 is the same as the probability that the z-score is between negative 1.67 and 1.33. We can use normal CDF again. Starting value here is negative 1.67. The ending value is 1.33. The mean is 0. Standard deviation is 1 because we are dealing with z-scores. And the probability ends up being 0.8557. And you can see that this answer is quite off, even though when you round it to 2 decimal places, we are going to get 0.86 here and 0.86 there. 0.8557 is off compared to 0.8609. The reason for that is that we rounded here and we rounded there when we computed the z-scores. So oftentimes using normal CDF with the mean and the standard deviation as is in the problem without using the z-score is going to be much more accurate than computing the z-scores, because each time you compute a z-score you will encounter rounding. The next topic is to find the value of a normal random variable. In the sense, we are trying to find the percentile or the position of an observation. Here is an example. The combined verbal and quantitative reasoning score on the GRE is normally distributed with mean 1049 and standard deviation is 189. What is the score of a student whose percentile rank is at the 85th percentile? So even before you start the problem, you can sort of identify the answer. We know 50% lies below the middle value, which is 1049, which is the mean and the standard deviation. So 85 perhaps lies somewhere over there. So that has to be P85 because we are adding 35% approximately to 50%. So we will put a note here that the answer has to be greater than 1049. Let's see if we get this. So we can find this using the calculator, but we can't use normal CDF. We have to use inverse norm. So P85 would imply 85% is below P85. So that's what the 85th percentile means. So we want to find P85. So the function is inverse norm. The area below or to the left, followed by the mean and the standard deviation. So, second vars, option number 3 is inverse norm. So you plug in the area below, which is 0.85, and the mean, which is 1049, standard deviation 189. So 0.85, 1049, 189. So we get 1244.885, which is approximately 1244.89. So earlier, even before we started the problem, we said the answer has to be greater than 1049, and it in fact is bigger than 1049. So moving on to the next problem, it is known that the length of a certain steel rod is normally distributed with mean 100 centimeters, which would mean the mean is right in the middle, it's 100 centimeters, and the standard deviation is 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the length of rods that make up the middle 90% of all steel rods. So all we know here is in the middle, we have an area or probability of 90%, which is 0.9. Now, how do we go about doing this? So we have to know that number and that number. This problem cannot be done without using z-scores. So how do we find the answer? So perhaps we can do it without using z-scores. Let's see, because we have inverse norm. So what we're going to do is we are going to find the area up there and the area up there. So if 90% is in the middle, 10% is unaccounted for, so 5% is over here and 5% is over there. So the area below the first measurement is 5%, and the area below that measurement is 95%, because we have 5%, we are adding 90% to this, so 90% plus 5% is 95%. So, since we know the area below, let's just call point A, so area below A is 5%, or simply 0.05, we can find that number using inverse norm. So inverse norm 0.05, the mean is 100, the standard deviation is 0.45. And that gives us, oh, sorry, wrong function. Number 3, 0.05, the area below, and 100, and 0.45. And we end up getting 99.2598, which is 26. Excuse me. We'll call the other endpoint as B, so that is B. Keep in mind, we know that the area above the point B is 5%, so the area below has to be 95%. So area below B is 95%, or 0.95. So we do inverse norm 0.95, 100, 0.45. And that gives us, I keep going to the wrong function. We have to use inverse norm. Inverse norm 0.95, 100, and 0.45. So we get 100.74 centimeters. So the length of the rods that make up the middle 90% of all steel rods manufactured would be between 99.26 centimeters and 100.74 centimeters. So inverse norm is quite essential with topics such as confidence intervals and hypothesis testing. It is a very, very important concept, so you understand how to find inverse norm thoroughly. So the notation Z sub alpha is the z-score such that the area under the standard normal curve, keep in mind, standard normal curve implies that the mean is 0 and the standard deviation is 1. So if we are looking for z sub alpha, the area to the right of z sub alpha is alpha. That is, if alpha is 0.05, then that area would be 0.05. If alpha is 0.1, then the area would be 0.1. And if the area, so let's put alpha, 0.05, 0.1, and 0.01. So that is the area to the right. Then the area to the left of z sub alpha would be the complement of each of those values, which should be 1 minus 0.05, which is 0.95, 1 minus 0.1, you get 0.9, 1 minus 0.01, we get 0.99. So we will know the areas, or we know the areas below Z alpha for each of the three alpha values that I considered, 0.05, 0.1, and 0.01. So we can use inverse norm for each case and find Z alpha. So case number 1, second vase, option 3, the area below or to the left of Z alpha is 0.95. The mean is 0, standard deviation is 1 because we are dealing with the standard normal curve, and the answer happens to be 1.645. So it's the second case. The area to the left of Z alpha or below Z alpha is 0.9, mean is 0, standard deviation is 1, and the answer is 1.28. Likewise, or 282. Likewise, the area to the left of Z sub alpha or below Z sub alpha is 0.99. So inverse norm 0.99. The mean is 0. Standard deviation is 1. We end up getting 2.326.